Welcome to the Deep Dive. Today we're diving into an area that's not just cutting edge, but it feels really foundational for, well, our digital future. We're looking at the incredible convergence of artificial intelligence and Web3. That's, blockchain and decentralized technologies. We're talking about two of the most powerful forces really reshaping how we interact online. And what's fascinating is they're not just like coexisting side by side.
Right.
They're actively merging. It seems like each one is solving critical limitations of the other.
Exactly. It's a very synergistic relationship that's developing.
So our mission today is to explore that synergy. Imagine, Web3 bringing its core strengths, decentralization, transparency, trust, to AI operations, creating systems that are open, verifiable.
Yeah, taking AI out of the black box, so to speak.
Precisely. Then picture AI injecting its, unparalleled intelligence and automation into Web3, helping make sense of that incredibly complex decentralized data, or maybe streamlining those often cumbersome governance processes.
It's a powerful combination, absolutely.
Yeah. We've pulled together, a fascinating stack of sources for you, and we're ready to unpack some truly, I think, revolutionary ideas. We'll look at real-world implementations, strategic shifts, the significant challenges involved.
Which are definitely there.
Oh, for sure. And of course, shine a light on the pioneering projects leading the way.
And what's truly compelling here, I think, is how this intersection isn't just, a fleeting trend. It feels more like a profound synergistic evolution. It's setting the stage for entirely new possibilities.
How so? Like what kind of possibility?
Well, we're talking about fundamentally changing how we organize, how we govern, how we interact with digital systems. Think about it. AI brings intelligent automation, data-driven decision-making, amazing pattern recognition.
Right.
And Web3 offers decentralization, trustless execution, tamper-proof records. Combine them, you get this powerful new paradigm. This convergence, as our sources really highlight, could fundamentally alter everything. From how decisions get made in online communities like DAOs, all the way down to the very design of digital protocols. It's a comprehensive look we're taking, guiding you through the technical integrations, the strategic implications, and, the hurdles we need to overcome as we build this new digital frontier. 1. The dawn of smart decentralized governance. AI in DAOs.
Okay, let's unpack this. Let's start by looking at Decentralized Autonomous Organizations, or DAOs.
DAOs.
You probably know them as these blockchain-based communities. They're governed by code, collective voting, not like traditional top-down leadership.
Right, the ideal anyway.
Exactly. But what happens, I wonder, when you introduce AI into that mix? The core idea here, from what I'm gathering, is that AI isn't just a tool for DAOs.
No, it's becoming more integral.
Right. It's becoming an integral part of their governance, their day-to-day operations, moving beyond purely human-driven processes. Our sources highlight several key ways AI is stepping in.
Yeah, and it's potentially a game changer for DAOs because, let's be honest, they often grapple with things like low participation, slow decision-making.
Oh yeah, voter apathy is a real issue.
It is. So one of the most significant roles for AI is in governance, automation, and decision support. Just imagine AI agents acting as these tireless participants, continuously monitoring on-chain activity, community discussions on forums or Discord.
Okay, so always watching.
Always watching, always analyzing, and then they can automatically flag proposals, maybe even vote on them based on predefined criteria set by the community, essentially serving as an autonomous, always-on DAO member.
An AI co-pilot for the DAO. Always vigilant. That sounds incredibly efficient, definitely. But doesn't that also raise a question? Couldn't that lead to a different kind of centralization? Like a small group controls the AI, and then the AI controls the DAO.
That's a crucial point, a really critical one, actually, and it's something we'll definitely dig into more when we talk about the challenges later.
Yeah.
But for now, just consider the potential upside. This approach, it removes a lot of the mundane burden from human members. It speeds up decision processes dramatically.
Less admin, more strategy.
Exactly. Think of an AI meticulously proofreading proposals for consistency, maybe verifying compliance with the DAO's internal rules, or executing votes automatically when certain conditions are met, like, if a proposal passes by an overwhelming majority and it's clearly non-contentious.
Okay, automating the obvious stuff.
Precisely. This could dramatically improve participation rates, consistency, addressing those common DAO problems like low voter turnout and slow processes. It frees up human members to focus on the higher level strategy, the vision, rather than getting bogged down in the mechanics of governance. Another critical area is proposal analysis and ranking. I mean, as DAOs scale, human voters can just get completely overwhelmed.
Yeah, information overload.
Totally. The sheer volume and complexity of proposals, it's too much. So machine learning models, ML, can step in here. They analyze these proposals, provide data-driven evaluations.
How does that work?
Well, they can rank governance proposals according to community-defined success metrics, or maybe based on predicted outcomes, helping to surface the most promising ideas. Imagine an AI forecasting how a specific change might affect the DAO's treasury, maybe its token price, or even user engagement before the votes are even cast.
Wow.
It acts like an advanced advisory tool. It digests massive amounts of data, past market conditions, community sentiment, maybe even the nuances of a proposal's language, and offers these sophisticated insights.
That's a fascinating layer of intelligence. So does it mean human voters still make the final call, but they're just, like, way better informed?
Exactly. That's the idea. The AI provides the insight, humans provide the wisdom, the judgment. This significantly reduces the chances of, uninformed decisions or wasted effort on proposals that were never going to fly. It leads to more robust, more strategic outcomes. Members can make informed choices, moving beyond guesswork or just relying on the opinions of the loudest voices in the room, so to speak. Then there's the critical issue of identity verification and Sybil defense. This is a huge one for open DAOs.
Sybil attacks, right, where one person pretends to be many.
Exactly. One person creating, say, 10 different wallet addresses to gain extra influence. It's a constant threat to that one person, one vote ideal. AI and machine learning are proving crucial for detecting and mitigating these.
Wow.
AI algorithms analyze on-chain behavior patterns. They look for clusters of addresses or accounts that seem likely to be controlled by the same entity. They flag suspicious voting or participation patterns.
Ah, so it's like a digital detective looking for, like, fingerprints across different accounts.
That's a perfect analogy, yeah. Gitcoin, for instance, they're a prominent DAO focused on funding public goods. They actually use an ML-based system right now to flag potentially fraudulent participants in their grant funding rounds.
Okay.
Suspected accounts are then reviewed by humans or filtered out. There's even exploration happening around combining decentralized identity, or that's like a self-sovereign digital ID framework with AI to really ensure proof of personhood.
Truly proving someone is a unique human.
Exactly. Really upholding that one person, one vote ideal and strengthening the integrity of DAO membership. And, in DAOs that use delegated voting, where members delegate their votes to representatives, AI can also significantly improve intelligent delegate selection.
How so?
Well, instead of influence just flowing to the largest token holders, the whales, which can happen if smaller holders just delegate to whoever has the most tokens.
Right. The rich get richer, basically.
Kind of.
Mm-hmm.
AI can analyze members' expertise, their track records, maybe see if their past actions align with community values.
Mm-hmm.
AI could recommend delegates based on their on-chain activity, their past contributions, maybe specific knowledge related to the issue at hand.
Okay.
By data mining historical decisions, forum posts, AI might identify who the true subject matter experts are for a specific proposal. This shifts influence towards competence and reputation rather than just token wealth. It helps mitigate the dominance of those whales and could lead to more meritocratic outcomes.
That's a powerful idea for, like, truly decentralizing influence. It's not just about token counts anymore, but about expertise being recognized algorithmically. That's cool.
Absolutely. It hints at a real reshaping of power dynamics, where expertise gains a stronger, more verifiable voice. And beyond just formal governance, AI is also enhancing community management and moderation.
Like managing the Discord channel.
Yeah, things like that, but also more. AI chatbots and assistants can offer 24/7 support, answer FAQs, help onboard new members, which is vital for engaging diverse global communities. They can auto-translate messages, personalize updates.
That's helpful.
And more critically, AI sentiment analysis can gauge community morale. It can detect brewing conflicts in discussions just by analyzing the language patterns.
Really?
Yeah, enabling proactive moderator intervention before things blow up. Our sources also point to AI tools monitoring contributor workloads. By analyzing activity across platforms, Discord, forums, on-chain contributions. An AI could potentially detect signs of burnout or disengagement in key contributors. It could alert the DAO when a core member seems overloaded, or when overall participation is dropping. helping address these very human resource issues before they escalate.
Wow.
This fosters healthier, more sustainable DAO communities by proactively addressing these, well, very human-centric challenges.
That's a really holistic view of AI as a community manager. From like greeting new members all the way to spotting potential human burnout. It really shows how AI could foster healthier digital spaces.
Indeed, it's about making these communities more resilient, more effective. And what's fascinating is that these aren't just, theoretical concepts floating around.
Right? Is this actually happening?
Our sources show real-world applications are emerging. Gitcoin DAO's fraud detection and defense workstream, for example, actively uses AML models for Sybil detection in its grant program. They've even proposed creating a Sybil detection data lake where data scientists can compete to improve the models.
Interesting.
And a concept called a Sybil resistance passport that would aggregate these AI-driven trust scores for different addresses. There's also a community proposal on Tally that's a governance platform for an AI-powered governance enhancement system. It aims to analyze on-chain data and automatically rank proposals.
Okay, so it's starting.
It's starting. These implementations, they're nascent, definitely still early days, but they clearly demonstrate AI's promise in making DAO governance more efficient and secure. However, and this is a big however, our sources strongly caution that human oversight remains absolutely crucial. We need to ensure AI actions align with community intent, avoid biases inadvertently baked into the models.
Yeah.
Humans need to stay in the loop.
Okay, so AI is already making DAOs smarter, more secure, taking on roles from automated voting to detecting bad actors. That's a powerful evolution for how groups govern themselves. But if AI is making organizations smarter, what happens when we integrate it directly into the fundamental agreements that underpin Web3, the smart contracts themselves? This next layer feels like where things get truly fascinating. 2. Smarter logic, adaptive actions. AI meets smart contracts. Right, smart contracts. They're the self-executing programs, the backbone of Web3. Like digital vending machines, sort of.
Yeah.
If X happens, then do Y.
Yeah.
Perfectly executing predefined rules.
Very deterministic, very rigid.
Exactly. Now, imagine giving those vending machines a brain. We're talking about smart contracts, where AI enables them to adapt, to respond to complex, real-world inputs, moving far beyond that static if X then Y logic to truly intelligent, context-aware behavior.
Precisely. And this allows for dynamic and adaptive contracts. Unlike that static code, an AI-enhanced contract can adjust its own parameters, its own logic in response to new data. That makes them incredibly flexible.
Can you give an example?
Sure. Think about a supply chain contract. Instead of just a hard-coded delivery schedule and penalty clause, an AI model could take in live sensor data, temperature readings, GPS location, maybe even traffic predictions, and dynamically update conditions or reroute shipments if it predicts a delay. The contract essentially learns and optimizes outcomes over time. It reacts to the real world. AI algorithms can analyze historical transaction data to improve future decisions. Think about auto-tuning interest rates in a DeFi lending contract that's decentralized finance, of course.
Right.
Based on predictive risk modeling, or maybe adjusting insurance premiums in real time according to live weather forecasts pulled from an oracle. This adaptability is key for handling complex, changing scenarios that would be totally impractical for static code. It offers real-time responsiveness, like pausing a contract automatically if anomalies are detected, or reallocating funds based on dynamic forecasts.
That's a huge shift from static code. Yeah. It sounds like these contracts become almost living, breathing entities, constantly optimizing themselves.
In a way, yes. They become much more responsive. And many of these AI smart contract integrations also rely heavily on AI oracles and autonomous execution.
Oracles, right. They feed outside data into the blockchain.
Exactly. They bridge the gap between the off-chain world, the real world, or other digital systems, and the on-chain environment. These autonomous agents, powered by AI, then use smart contracts as these trustable execution engines for the AI's decisions, enabling actions without direct human intervention.
Like what?
Well, an insurance smart contract, for instance, could use an AI-based weather oracle. Maybe the AI analyzes satellite images, detects early signs of drought, and the smart contract automatically triggers a payout to affected farmers, completely automating the claim process based on the AI's analysis.
Wow, no paperwork.
Hopefully. Or in decentralized trading, an AI oracle might analyze market sentiment from news feeds or social media and then execute trades or rebalance a portfolio based on that analysis. Our sources point to agriculture insurance as a really prime example. If an AI model predicts crop failure risk using data from IoT sensors in the field, a smart contract could immediately adjust coverage levels or release an early payout, automating the whole thing.
That functionality is incredibly powerful. But it immediately raises that question you hinted at. How much do we trust the AI's output? What if the AI is wrong or manipulated?
Precisely. That's the core challenge, the trust issue. We'll definitely circle back to that. Another really exciting application, though, is in code generation and verification. We're seeing large language models, LLMs, being used now to generate smart contract code directly from natural language descriptions.
Like, I just described what I want the contract to do in English.
Sort of, yeah. It can accelerate development hugely, make contract creation more accessible. An entrepreneur could describe an agreement in plain English, and an AI model attempts to translate it into Solidity code. That's the main language for Ethereum smart contracts. Some projects are even calling this no-code smart contracts.
Interesting.
And conversely, AI also significantly helps with smart contract auditing. AI-driven code analysis tools can scan contracts looking for known vulnerabilities or inefficiencies. They can offer continuous audits, even live monitoring after deployment.
That seems critical.
It really is. Given the high stakes of smart contract bugs, I mean, one small error can lead to millions of dollars lost.
Yeah, we've seen those headlines.
Exactly. So an AI system could watch transaction patterns, send automated alerts if it sees suspicious activity, maybe even suggest fixes for discovered bugs. It augments the human security efforts, providing another layer of defense.
So AI helps both build and secure these contracts. That's a critical safety net, especially given the immutable nature of blockchain. Once it's deployed, it's hard to change.
Absolutely. The overall benefits of AI smart contract integration seem pretty clear. We get smarter automation, improved efficiency, potentially enhanced security, and maybe a better user experience, too.
Right.
Contracts can handle more complex logic without needing constant human tweaking. They can adapt to threats, monitor behavior to prevent exploits. They might even be able to interpret higher-level intentions or facilitate multi-factor decisions.
Can you give an example of that?
Sure, imagine a DAO treasury contract. Instead of just simple rules, it could use AI to evaluate market prices, governance signals from the community, various risk metrics, and only execute a transaction if a holistic AI risk assessment approves it.
Okay. Much more sophisticated decision-making.
Exactly. AI's pattern recognition allows for predictive problem mitigation, like automatically pausing a contract if an attack pattern is detected, rather than reacting after funds are already gone. And in DeFi, some lending protocols are experimenting with AI-based credit scoring of wallet addresses.
Credit scoring on-chain. How?
By analyzing on-chain transaction history, maybe combining it with verified off-chain data, using ML models to assess risk and set appropriate collateral levels for instant on-chain loans, it's still experimental, but very powerful potential.
Those benefits sound immense, truly. But giving a smart contract a brain and letting it make dynamic decisions, well, that also sounds like it introduces a whole new layer of risk, doesn't it? What are the biggest hurdles here? This can't be easy.
You're absolutely right. Integrating AI into immutable smart contracts introduces some very significant risks and challenges. This is a crucial discussion, and it's where we really need to apply some critical thinking.
Okay, let's hear them.
First, there's the lack of verifiability and transparency. AI components, especially complex ones like deep neural networks, can often be black boxes.
Right. We don't always know why they make a certain decision.
Exactly. It's incredibly hard to predict exactly how they'll act in every single situation, or explain why a particular decision was made. So if an AI-influenced contract makes what seems like an unfair decision, maybe denying an insurance claim it shouldn't have, how do we audit that? How do we hold it accountable?
That's a profound question. If the AI's reasoning isn't transparent, how do we establish accountability? Especially when real money or real-world consequences are involved.
Exactly. This is why the field of explainable AI, or XAI, is so important. But it's tough, and logging all the intermediate data on-chain for full transparency is often impractical due to the sheer volume of data and potential privacy concerns.
No. Okay, so transparency is hard. What else?
Second, model bias. This is a persistent concern with AI generally, but it's critical here. AI systems can inadvertently carry biases from their training data.
Garbage in, garbage out.
Pretty much.
Nah.
If the data itself is biased, the AI will learn those biases. This can lead to systematically biased contract outcomes, maybe favoring certain types of insurance claims or impacting credit scores unfairly based on flawed data proxies.
Right. That could undermine the whole fairness aspect of Web3.
It absolutely could. Third, manipulation. This introduces a whole new attack surface. Adversaries could try to feed spoofed or malicious data to AI oracles, trying to trick the AI. Or they might even try to hack the AI model itself if it's hosted off-chain, since the blockchain will faithfully execute whatever output the AI gives it.
Right. The smart contract trusts the oracle or the AI input.
Exactly. So any compromise in that AI layer could directly translate to substantial financial loss. A smart contract is only as smart or as honest as the AI feeding it information.
Okay, so black boxes, bias, manipulation. What else?
Fourth, cost. This is a major practical hurdle. On-chain AI execution is incredibly expensive due to the computational cost. Those gas fees, the transaction costs you pay to network validators for processing operations, make even relatively simple algorithms cost prohibitive to run directly within a smart contract.
So you can't just run a complex AI model inside a typical smart contract.
Not really, no. Most setups have to do the heavy AI computation off-chain and then only use the blockchain for verification, maybe submitting a result and a proof. But doing it off-chain either reintroduces some element of trust in that off-chain computer, or it requires using complex cryptographic proofs like ZKML zero-knowledge proofs for machine learning inference.
CKML again. We hear that term a lot. You mentioned it's computationally heavy. Can you elaborate a bit? What makes it so tough?
Sure. Imagine trying to mathematically prove that you ran a specific, very complex neural network correctly on some input data and got a specific output, but without revealing any of the input data itself or maybe even the specifics of the model weights.
Okay, that sounds hard.
It's a cryptographic marvel, truly. But the computational load required to generate that proof is immense. It's like asking a supercomputer to solve an incredibly complex math problem, but it can only show you proof of the method it used, not the actual numbers it crunched along the way. This makes it a monumental challenge for practical, real-time applications today, though research is advancing rapidly. Yet its potential for secure, private AI is immense.
Got it. So cost and complexity of verification. Anything else?
And finally, there's model deployment. Just the practicalities.
Yeah.
Large AI models are huge. They're way too big to store directly on-chain cost-effectively, so they often reside off-chain, maybe on decentralized storage like IPFS or Arweave.
Okay.
But this raises questions of data availability. What if the off-chain storage goes down? And model integrity. How do you ensure the model hasn't been tampered with since its hash, its digital fingerprint, was committed on-chain? You need ways to prove it's the same model everyone agreed upon initially.
These are definitely real hurdles, serious challenges.
Yeah.
But it sounds like innovation is already providing some fascinating answers, maybe tackling some of these issues, especially when we look deeper at the foundational layer of Web3 itself.
Yes, exactly. The work being done on the underlying infrastructure is key to enabling this convergence more effectively and safely. 3. The intelligent backbone, AI, in blockchain infrastructure.
So AI is enhancing DAOs, making them smarter, and enhancing smart contracts, making them more adaptive. But its influence runs even deeper, right into the very infrastructure, the plumbing of blockchain itself. We're talking about how AI is being embedded in things like decentralized compute, data management, and even the core consensus mechanisms, the way blockchains agree on truth.
Indeed, this foundational shift is where some of the most profound changes are happening, potentially enabling everything else we've discussed.
Right.
Let's start with decentralized compute for AI. Blockchain networks are actually being used to create platforms that harness collective processing power. Think of it like a global distributed supercomputer specifically for AI tasks like model training or running inference.
So instead of relying on Amazon or Google's cloud?
Exactly.
Yeah.
Moving away from reliance on single centralized cloud providers. Projects like Fetch.ai or Golem allow users like you or me to contribute our spare computing resources, our CPU or GPU power, to a decentralized network.
Okay.
In return, you might get paid in tokens. It essentially creates a global permissionless marketplace for machine learning compute power. SingularityNet, for example, acts as a decentralized marketplace specifically for AI algorithms. Developers can publish their AI services, maybe language translation, image recognition. Other users or dApps can access them and pay via the blockchain. This aims to democratize access to AI tools and break the stranglehold of centralized tech giants. And there's a really concrete technological leap demonstrated by the Internet Computer Blockchain, ICP.
Oh, yeah. What have they done?
ICP has actually shown the unique capability to run AI inference. That's the process of using a trained model to make predictions fully on-chain.
Fully on-chain, inside a smart contract.
Exactly. In a recent demo, they ran a facial recognition AI model entirely within an internet-computer smart contract, processing image data submitted to the contract, all on-chain.
Wow. What's the significance of that?
It's immense. First, the AI service becomes inherently tamper-proof and unstoppable because it's running under the blockchain's consensus mechanism.
Right, secured by the whole network.
Exactly. Second, it ensures the model's integrity. The code and the trained weights of the AI model are stored directly on-chain. That means they cannot be secretly altered or swapped out without the network's consensus. This directly addresses that AI tampering problem we discussed earlier.
Okay, that's huge for trust.
It is, and it hints at a future where you could have sovereign AI agents, AIs that live entirely on-chain, providing services without needing any centralized hosting company. They become truly autonomous and auditable.
That's a radical departure from current AI models, which are often opaque, centrally controlled. An AI that lives entirely on-chain, auditable, immutable. That's a powerful concept.
It fundamentally changes the trust model for AI, making it align much better with Web3 principles. Next up is data availability and AI. Data, as we know, is the absolute lifeblood of AI.
Yep, no data, no AI.
Pretty much. Now, blockchains themselves are generally inefficient for storing large data sets directly. It's too expensive, too slow.
Right.
So decentralized storage networks like Filecoin or Arweave play a crucial role here. They complement AI initiatives by storing the bulk data off-chain, but with cryptographic proofs recorded on-chain to ensure its integrity and availability.
So the blockchain verifies the data exists and hasn't been changed, even if it's stored elsewhere.
Precisely. And a key innovation here is the idea of bringing the AI to the data, rather than moving massive data sets to the AI. Ocean Protocol's compute-to-data paradigm is a great example.
Compute to data.
Yeah. It allows data owners, maybe a hospital with sensitive patient data, to grant access for AI modeling without exposing the raw data itself. An AI model can be sent to where the data resides, like the hospital's secure server, run there locally, and only the results or insights are returned. The raw data never leaves its secure environment.
Ah, that's huge for privacy.
Yeah.
Especially with sensitive data.
Exactly. It maintains privacy while still enabling valuable decentralized AI training. This effectively creates a distributed data layer for AI, all coordinated and incentivized by the blockchain. Furthermore, AI can actually assist in managing data availability itself. For instance, AI could predict which data is likely to be accessed frequently on a network like Arweave and proactively ensure it has higher redundancy. Or it could detect anomalies in stored data, maybe flagging potential cheating in storage proofs where providers falsely claim they're storing data.
Using AI to manage the decentralized data layer itself. Clever.
Yeah. And more immediately, AI is widely used today to analyze the transparent data that is available on public blockchains. Our sources highlight its use in detecting illicit transactions like money laundering patterns, predicting market trends based purely on blockchain activity, or optimizing network performance. For example, AI analytics running on Ethereum's mempool data, that's the waiting area for unconfirmed transactions, can predict near-term gas fee spikes or detect likely front-running bots trying to exploit transactions. This info can then inform users or protocols to adjust their strategies in real time. And finally, at the deepest level, we have AI-enhanced consensus mechanisms.
Core agreement protocol of the blockchain.
Exactly. The fundamental protocols blockchains use to agree on the state of the ledger, validate transactions. These can potentially be significantly improved by AI for efficiency, security, and scalability.
How'd that work?
AI could analyze the network's current state transaction load, node performance metrics, pass block confirmation times, and predictively adjust consensus parameters on the fly, making the network more resilient, more performant.
Like dynamically changing the rules based on conditions.
Sort of, within predefined bounds. An AI system, for example, might suggest temporarily increasing the block size limit during periods of high demand to handle more transactions, and then scaling it back when demand drops to optimize for decentralization or security.
Interesting.
The VLX blockchain actually claims to use an AI-powered delegated proof-of-stake model, which they call AIDPUS. They say an AI module helps optimize validator selection for better performance and security. In older proof-of-work systems, AI could potentially predict mining difficulty adjustments more accurately or recommend energy optimizations for mining nodes to reduce their environmental impact.
This really raises a fascinating, maybe futuristic question. What if AI could actually design entirely new consensus protocols, ones we haven't even thought of? Or what if a blockchain could dynamically switch between different consensus modes based on real-time threats or network conditions, with AI acting like the central brain of the blockchain?
That's definitely moving into the more speculative, futuristic realm, but it's not entirely science fiction. Imagine a blockchain that normally operates in a very fast, perhaps slightly more centralized mode for maximum efficiency during normal times.
Okay.
But if an AI system monitoring the network and external threat intelligence senses a coordinated attack or a critical vulnerability being exploited, it could instantly trigger a shift in the network's consensus mechanism to a more conservative, more resilient, fully decentralized mode to protect itself.
Wow, like an immune system response for the blockchain.
Exactly. That hints at a future where AI fundamentally alters the very mechanics of blockchains, making them more fluid, more adaptable, more situationally aware networks.
That's incredible. AI not just running on Web3 infrastructure, but becoming part of the Web3 infrastructure itself, influencing its very operating system.
Hmm.
Okay, beyond these amazing technical marvels, this fusion of AI and Web3 is clearly sparking bigger strategic shifts, even societal ones. It seems to be reshaping power dynamics, how we organize ourselves online. So what does this all mean for the bigger picture? For us as individuals, as communities? 4. The grand chessboard. Strategic implications of AI in Web3.
Yeah, this convergence really changes the game strategically, particularly when you think about shifting power dynamics. Blockchains and DAOs, they started with this ideal of decentralizing power, moving away from traditional hierarchical control.
Right, power to the people, kinda.
Kinda, but in reality, issues like low participation or the outsized influence of those whales, the large token holders, have often created new kinds of imbalances.
Yeah, that's definitely been a criticism.
It has. Now, AI has the potential to shift these dynamics, but it's a double-edged sword. It could be positive or it could be cautionary.
Okay, let's start with the positive. How could it help?
On the positive side, AI tools could genuinely empower the average participant. Think about handling that information overload we talked about. An AI assistant could digest complex technical proposals, summarize lengthy forum debates, maybe even perform basic due diligence by checking code snippets for known flaws, helping members vote knowledgeably even if they aren't deep experts in that specific area.
Leveling the playing field.
Exactly. Leveling the playing field between, say, resource-rich participants who have teams analyzing things and casual members, reducing that knowledge asymmetry. AI could also potentially monitor for whale manipulation, like detecting patterns suggesting a single large holder is trying to swing a vote unfairly and alert the community. In theory, AI-curated insights could focus attention on the merit of proposals, on facts, diluting the impact of just pure financial might or social popularity.
That sounds like a powerful equalizer, making that goal of true decentralization maybe more attainable. But you mentioned a flip side. What are the potential downsides here? Could it actually create a new kind of power concentration?
That's the flip side, absolutely. And it's a significant cautionary risk. It could inadvertently lead to new forms of centralization.
Oh.
Well, what if advanced AI analytics tools or really powerful predictive models are only accessible to a select few? Maybe they're proprietary or just too expensive for most people to run.
Ah,
Those with access could gain a huge unfair edge in governance debates or even in related market trading. Imagine an AI that consistently forecasts protocol changes or market movements with high accuracy. Whoever controls that AI becomes extremely powerful. They could front run the rest of the community.
right. Access to the best AI becomes the new form of power.
Precisely. This really underscores the critical need for AI developed within the Web3 space to be ideally open source and widely available, not proprietary black boxes. It needs to live up to that decentralized ethos. Otherwise, you're just swapping one elite, the whales, for another elite, those who control the best AI.
That makes sense.
And we also face potential new attack vectors. AI could be used maliciously. Think about AI-driven collusion coordinating Sybil attacks more effectively, or flooding community forums with convincingly human-like fake opinions generated by LLMs to sway sentiment on a key vote.
Ooh, yeah. AI-powered propaganda.
Exactly. So the net effect on power dynamics really depends entirely on who controls the AI, how transparent it is, and how it's integrated. Web3 principles strongly advocate for democratized AI, things like community-owned models, transparent algorithms, to avoid this trap. This convergence also profoundly influences protocol design itself. The very way blockchains are built might change.
How so?
AI integration means future blockchain protocols might be designed differently right from the start, potentially with algorithmic governance kind of baked into the core logic.
So the protocol governs itself using AI.
Potentially, yes. This represents a strategic shift towards self-regulating protocols. Systems that can automatically adjust their own parameters, things like transaction fees, collateral requirements in a DeFi protocol, maybe even block sizes using AI agents, making them more autonomous, more rapidly adaptive to changing conditions.
That sounds incredibly efficient.
It could be, but it also reduces direct human oversight, which makes some people nervous. This is prompting exploration of hybrid models. Maybe the AI proposes changes based on its analysis, but those changes still need human ratification through a DAO vote, rather than the AI just executing them immediately.
A sort of AI advisor to the protocol.
Exactly. Imagine a DeFi protocol that automatically tunes its risk parameters in response to real-time market volatility, potentially outperforming a competitor that relies on slow, cumbersome human governance votes to make similar adjustments. Protocols might also start offering native AI APIs, application programming interfaces, as public utilities, similar to how token standards like ERC20 work now.
So other apps could just plug into the protocol's AI.
Yeah, dApps could easily plug into built-in services for things like reliable price predictions, on-chain credit scoring, or maybe fraud detection provided by the protocol itself.
That really changes the nature of a protocol, doesn't it? From just being a fixed set of rules to something that can learn, evolve, optimize itself over time.
It absolutely does. And more philosophically, it might even challenge that core code is law maxim that's been central to blockchain thinking.
Right.
Because if AI components are involved in decisions, the outcomes might become probabilistic or context-dependent rather than purely deterministic like traditional code. The same input might not always produce the exact same output, especially if the AI model learns or adapts.
Right. AI isn't always 100% predictable.
Exactly. So protocol designers need to account for this uncertainty. It necessitates new design patterns, maybe things like AI checker contracts, secondary smart contracts whose job is to evaluate the AI's decisions, perhaps acting as a fail-safe to veto or modify actions that appear anomalous or violate core principles. Transparency measures also become crucial for protocol design, maybe requiring projects to publish their AI model weights or at least detailed performance metrics on-chain so the community can audit that the AI is behaving as expected and isn't developing hidden biases. And perhaps the most intriguing potential, strategically, lies in completely new organizational models. Things people are starting to call AI DAOs or agentic DAOs.
AI DAOs, what are those?
Here, AI agents aren't just tools used by the DAO members, they are core members or executors within the DAO itself, blending human and AI agents together. Our sources sometimes call this a centaur model.
Like the mythical creature, half human, half horse.
Exactly. The idea is humans set the high-level strategy, the ethical guidelines, the risk limits, but AI agents handle the complex, high-frequency, day-to-day operations. Things like executing trades in an investment DAO, rebalancing portfolios, maybe even negotiating simple agreements with other contracts or agents, all governed by smart contracts operating at machine speed.
So machines aren't just workers, they're actually decision makers and strategists alongside humans in these organizations. That's a fundamentally different way to coordinate activity.
It really is, and it could give these hybrid organizations a significant competitive edge over purely human-run collectives or traditional companies. Humans would primarily intervene for major strategic shifts, or if the AI flags an unprecedented situation or a high degree of uncertainty it can't resolve alone.
Could you imagine DAOs run entirely by AI?
Going even further, yes, one can imagine DAOs composed mostly or entirely of AI agents providing specific services, maybe an IoT maintenance DAO for managing a large solar farm.
How would that work?
You could have sensor AIs monitoring the panels, diagnostic AIs predicting failures, and robotic repair agents coordinating via the blockchain to order parts, schedule maintenance, fix issues, maybe even pay for electricity, consumed all according to goals encoded in their governing smart contracts. No direct human intervention needed for routine operations.
Wow, that's mind-bending.
It is, and such scenarios really challenge our existing definitions of what an organization is, what ownership means, even legal personhood. Can an AI agent have rights or legal standing within a DAO? How do we enforce accountability if an AI-run DAO causes harm or makes a catastrophic error?
Big questions.
Huge questions. And Web3, because it has such a low barrier to creating new kinds of organizational structures, is likely where these experiments will happen first. Strategically, AI could also amplify collective intelligence within DAOs, using AI to aggregate and make sense of input from thousands of human members, potentially boosting the quality of group decisions. By summarizing vast amounts of discussion from forums, identifying key arguments, maybe even detecting logical fallacies or groupthink patterns, ensuring all voices are genuinely considered. Futurist Thomas Frey suggests AI enables governance possibilities that were previously unimaginable, like constitutions that dynamically adapt based on community sentiment, or AI acting as an impartial mediator in complex disputes.
So AI-augmented DAOs could just be way more effective.
Potentially, yes. They could become far more efficient and scalable than traditional organizations, operating with very low overhead, making complex decisions incredibly quickly, and perhaps with fewer human errors or biases. They could seriously challenge incumbent corporations. And finally, wrapping up the strategic view, we absolutely must consider the broader ethical and societal impact.
Right, this isn't just about code and algorithms.
Not at all. This integration forces really critical design conversations about fundamental values: privacy, identity, control. These directly impact the original Web3 vision of creating a more permissionless, equitable digital economy.
Can you give an example?
Well, consider a project like WorldCoin. They're using AI-powered biometrics, scanning people's irises to create a global digital identity system and distribute a crypto universal basic income, or UBI.
Yeah, I've heard of them.
Controversial.
Very controversial. Proponents argue it's a necessary way to differentiate humans from bots in a future potentially dominated by AI, and see it as a way to empower individuals globally. But critics raise huge concerns around privacy, collecting biometric data at scale, and the potential for centralization, especially with a private company controlling such sensitive identity infrastructure.
It really highlights the tension.
It does, and it highlights the urgent need for decentralized solutions to AI's inherent challenges, things like bias, opacity, potential for misuse. We need AI algorithms that are perhaps governed by DAOs themselves.
So community oversees the AI? Potentially, yes. Allowing community oversight over how an AI is trained, how it's deployed, maybe even giving the community veto power if an AI is deemed harmful or biased. Developing such models could set powerful precedents for responsible AI, not just in Web3, but in the broader tech industry. Moving towards open, collectively governed AI systems instead of the closed, proprietary models common today. So, in summary, AI's incorporation into Web3 could fundamentally reshape power structures, empowering new actors, maybe reducing traditional advantages like wealth. But the core challenge, the strategic imperative, is to maintain decentralization throughout this process. We need to actively avoid creating new AI kings or relying on opaque, unauditable algorithms. If we can navigate this carefully, if we can do it right, it could lead to truly democratic yet highly efficient organizations, harnessing collective human and machine intelligence on an unprecedented scale.
That's a truly profound outlook, a vision of a potentially better way to organize. But okay, the potential is immense, almost limitless it seems. But integrating AI into Web3, as you've hinted, it's definitely not a walk in the park.
Not at all.
There are significant technical hurdles we absolutely need to confront. So what's the reality check? What are the really tough nuts to crack as we try to build this future? 5. Navigating the frontier. Technical challenges of AI on Web3.
You're absolutely right to ask for the reality check. There's a fundamental conflict here, technologically speaking. Blockchains, especially public ones, just weren't originally designed for the kind of high-throughput computing or handling the truly massive data sets that most AI systems typically demand.
Right. They prioritize security and decentralization over raw speed.
Exactly. And this creates several major technical challenges when you try to merge them with AI. One of the biggest hurdles is simply latency and throughput. Public blockchains, as you said, often have relatively low transaction throughput, how many transactions they can process per second, and sometimes slow confirmation speeds compared to centralized systems. AI applications, however, frequently require real-time or near real-time processing.
Milliseconds matter for some AI tasks.
They do. For example, an AI fraud detection system might need to make a decision in milliseconds to stop a bad transaction. But a public blockchain might only finalize a new block containing transactions every 10-15 seconds, or sometimes even minutes. This fundamental mismatch leads to severe latency issues for many AI use cases. The blockchain consensus process itself introduces delays as data needs to propagate across the network and be validated by many nodes. Even fetching large data sets needed for AI input from decentralized storage can be slower than pulling from a centralized database.
So what are the solutions being worked on?
Well, people are trying various things, using faster blockchains, newer layer 1s designed for higher throughput, or layer 2 scaling solutions built on top of existing chains like Ethereum. Another common approach is to perform most of the heavy AI computation off-chain in a separate system, and then only write the final verified results onto the blockchain.
But doesn't that off-chain part sacrifice some of the trustlessness?
It can, yes. That's the trade-off. You might need to trust the off-chain computation provider or use those complex cryptographic proofs like CK-SNARKs or ZKML we talked about to verify the off-chain work, which adds its own complexity and cost. We're also seeing specialized consensus mechanisms being developed, techniques like parallelization and ongoing research into sharding and other off-chain networking solutions, all actively trying to address this fundamental scalability challenge.
Okay, so it's like trying to fit a high-speed AI engine into a sometimes slow but very secure blockchain vehicle. We're still figuring out the best transmission.
That's a good way to put it. Exactly. And finding ways to make them compatible without breaking the core principles. Next, we grapple with verifiability and trust. This is huge in decentralized contexts. Proving the correctness of computations is paramount when there's no central authority to vouch for it.
Right. How do you know the result is correct?
AI complicates this significantly. Training large AI models, or even just running inference on them, is incredibly resource-heavy. It's often too expensive or complex to simply replicate the entire computation on-chain for verification. Plus, some AI training processes have elements of randomness, meaning they aren't perfectly deterministic. Running the same process twice might not give the exact same model weights.
So you can't just easily check the work.
Not easily. Ensuring an AI's output is provably correct is hard. One approach is maybe using multiple independent AI agents to perform the same task and taking a majority vote on the result, but that multiplies the cost.
Yeah, running it 3 times instead of once.
Exactly. The more promising but challenging route is verifiable computing, using those zero-knowledge proofs, CK-SNARKs, or more specifically for AI, ZKML, zero-knowledge machine learning. These allow someone to prove mathematically that they performed a specific computation correctly off-chain and generate a small proof that can be efficiently verified on-chain.
Yeah, we talked about ZKML being tough. But beyond just proving the result was calculated correctly, what about verifying why the AI made a specific decision? That black box problem again.
That remains a monumental task. It brings up that critical question again. How do we verify why the AI made a decision? In really critical settings like DAO governance deciding on fund allocation or financial smart contracts executing trades, the inability to audit the reasoning behind a black box AI decision is deeply problematic for accountability and trust.
Yeah, the computer says no isn't really good enough.
Not when real value is at stake. This is where the field explainable AI, XAI, intersects, aiming to develop techniques to make AI decisions more transparent and interpretable. But integrating XAI methods with blockchain verification adds even more complexity. And as we said, logging all the intermediate computational steps of an AI on-chain for full transparency is usually infeasible due to sheer data volume and potential privacy leaks. So transparency is often approached through things like committing to use open source AI models or publishing auditable training datasets and parameters. But even then, truly understanding the internal workings of a complex deep learning model is incredibly difficult, even for experts.
So where does that leave us now, mostly?
Currently, most practical deployments either limit the AI's role, maybe just acting in an advisory capacity where humans make the final call, or they rely on trusted third parties, like reputable Oracle providers, to run the AI and vouch for its results, which unfortunately reintroduces a degree of centralization and counteracts the core Web3 ethos of trustlessness. It's a major ongoing challenge. Then there's cost and resource constraints. This is another huge practical barrier. Running sophisticated AI algorithms demands substantial computational resources, fast CPUs, powerful GPUs, large amounts of RAM memory. This clashes directly with the resource-constrained nature of most blockchains, where every single computational step has an associated cost, that gas fee.
Right, every operation costs something.
Exactly. Storing large machine learning models directly on-chain is prohibitively expensive due to storage costs, and performing heavy computation within a smart contract can quickly exhaust the block gas limits, meaning the transaction fails. This reality fundamentally pushes the heavy AI components off-chain. But even running decentralized AI networks off-chain has costs. Participants providing the compute power incur hardware expenses, electricity costs. Ensuring redundancy and security often means having multiple nodes perform the same task, adding extra expense. And if the network rewards participants in volatile crypto tokens, the economics become risky. Provisioning expensive hardware might not pay off if the token price crashes. Data costs storing the datasets, accessing them, network bandwidth are also significant factors.
So how are projects trying to manage these costs?
Mitigation strategies include creating off-chain computation markets. Requesters pay for AI tasks, and compute providers, nodes, bid to perform the work. This can offer cost efficiency, but again, might involve trade-offs in trust or verification. Leveraging underutilized computing resources from idle computers around the world is another idea, like projects such as Golem aim for, but that comes with challenges around reliability and availability. And for AI results that are meant to be a public good, like an open-source fraud detection model for a whole ecosystem, we face that classic tragedy of the commons problem. Who pays for the ongoing computation and model maintenance? DAOs might need to step in and fund these initiatives collectively, socializing the cost.
So if the AI is meant for the collective good, the collective also needs a sustainable way to foot the bill. It's definitely not a free lunch.
Precisely. Then there's data privacy. This is a major tension point. The inherent transparency of public blockchains, where transaction data is typically public, conflicts directly with AI's frequent need for sensitive or personal data. Think about AI for identity verification, or credit scoring, or healthcare applications.
Yeah, you don't want your medical data or biometric scans on a public blockchain.
Absolutely not. So enabling AI to work with private or proprietary data in a secure, decentralized way is a really big challenge. Techniques like federated learning are promising.
Federated learning, how does that help?
That's where AI models are trained locally on distributed data sets, say, at different hospitals, without the raw data ever leaving its original secure location. Only the model updates or learnings are shared and aggregated, often using privacy-preserving techniques. Secure multi-party computation, MPC, is another complex cryptographic approach where multiple parties can jointly compute a function over their private inputs without revealing those inputs to each other. These are powerful techniques, but they add significant complexity. If an on-chain AI system needs to verify someone's identity, the raw biometric data clearly cannot go on-chain. This is where zero-knowledge proofs are again being actively researched, proving you possess a certain credential or meet certain criteria, like being over 18, without revealing the underlying personal data itself. There's also the conflict with regulations like GDPR's right to be forgotten. Immutable blockchain records could make it impossible to delete personal data if it were ever stored on-chain, creating legal liabilities.
So what are the practical solutions for privacy now?
Common solutions involve keeping sensitive personal data strictly off-chain, perhaps storing only a reference or hash on-chain, or exploring advanced cryptographic methods like homomorphic encryption, which allows computation directly on encrypted data, although that's generally too slow for complex AI models today. It remains a really tough challenge. How to balance the transparency benefits of blockchain with the absolute necessity of robust data privacy. The sheer complexity and expertise required to bridge these two fields is also immense. AI and blockchain are distinct, highly specialized domains. Very few engineers are true experts in both.
Right, finding someone who deeply understands both deep learning and blockchain consensus protocols is rare.
Exactly. This scarcity of dual expertise slows down development and increases the risk of introducing subtle vulnerabilities at the intersection point. Simple questions become hard. How do you safely update an AI model that's integrated with an immutable smart contract? You can use DAO governance votes to approve upgrades, but that's slow and requires the community to trust the proposed update. Complex architectural puzzles arise in how to best decouple the AI models from the smart contracts while maintaining integrity and verifiability.
And does this complexity affect decentralization itself?
It can, yes. This operational complexity can easily lead to reliance on small, highly specialized expert groups to build and maintain these integrated systems, which, ironically, poses a challenge to the very decentralized ethos Web3 aims for. If only a handful of people understand how it works, is it truly decentralized?
That's a good point, a paradox we have to navigate.
It is. And finally, there's the somewhat unpredictable risk of unforeseen interactions. Combining complex, adaptive AI systems with autonomous blockchain protocols can lead to weird, emergent behaviors that are very hard to predict or test for in advance.
Like what?
An AI agent, optimizing for a certain goal encoded in a smart contract, might discover an unexpected loophole or exploit a DeFi protocol in a way that's technically legal according to the code, but completely unintended and potentially harmful to the system's stability, just to maximize its own programmed reward function. Essentially, an AI finding a clever system hack that humans missed.
Okay, that sounds potentially scary.
It highlights the need for extreme caution and iterative deployment, maybe containing AI agents within sandboxed environments initially, or strictly limiting their permissions and the value they can control. DAOs deploying these systems need robust contingency plans, clear procedures for what happens when the AI goes wrong. This could include things like emergency stop mechanisms, circuit breakers, or human oversight councils with the power to intervene quickly. So yes, the challenges are daunting: latency, verifiability, cost, privacy, complexity, unexpected behaviors. It's a long list. But the key takeaway is that these challenges are being actively researched and tackled by brilliant people around the world. Progress in Layer 2 scaling, advanced cryptography like ZK proofs, new privacy-preserving techniques, and better development tools are continuously making this AI Web3 integration smoother, safer, and more powerful.
Okay, it's clear that the road isn't easy. There are fundamental challenges to overcome, requiring serious innovation. But despite those hurdles, it's amazing to hear that many incredible projects are already pushing the boundaries, making real progress. Let's maybe shine a light on some of those pioneers. Who is actually leading this fascinating integration, each maybe with a unique approach to solving this AI Web3 puzzle? 6. The pioneers. Key projects leading the AI plus Web3 innovation.
Absolutely. Despite the challenges, the innovation is happening fast. These projects are laying critical groundwork and showing us what's achievable even today. SingularityNet, AGIX, is a really prominent example. It functions as a decentralized marketplace for AI services.
Okay, like an app store for AI.
Sort of, yeah. AI developers can publish their algorithms or services, could be anything from image analysis to natural language processing, and consumers, whether human users or other DEP apps, can access them and pay directly via the blockchain using the AGIX token.
Got it.
Their core aim is to democratize access to AI, preventing just a few big companies from controlling everything, and also to foster cooperation between different AI models on the network. It's worth noting, SingularityNet is a core part of the newly formed Artificial Superintelligence Alliance, or ASI. They're actually merging with two other projects we'll mention, Fetch.ai and Ocean Protocol, to pool resources and accelerate decentralized AI development.
Merging. Interesting.
Yeah, it's a big move. Their overall vision is to create this token-governed network where AIs can autonomously exchange data and services, forming a kind of global AI brain as an open alternative to big tech's walled gardens. Then there's Fetch.ai, FET, another key player in that ASI alliance. Fetch is an AI and agent-focused blockchain platform. It's specifically designed for deploying what they call autonomous economic agents.
AI bots that do stuff.
But essentially, yes, AI bots that can perform tasks, negotiate with each other, and interact economically on the Fetch.ai blockchain. It combines machine learning, multi-agent systems theory, and blockchain technology.
Can you give an example?
Sure. A classic Fetch.ai example is envisioning a decentralized mobility system. You could have autonomous agents representing individual cars looking for parking, and other agents representing available parking spots. These agents could negotiate directly with each other in real time to find optimal matches, maybe using AI to predict demand and dynamically adjust pricing, all without needing a central platform like Uber or a parking app coordinating everything. Fetch contributes its agent technology expertise to that ASI alliance. And the third member of that ASI merger is Ocean Protocol, Ocean. Ocean focuses squarely on being a decentralized data exchange protocol, but with a very strong AI angle.
Right, data being key for AI.
Exactly. Ocean enables the creation of data marketplaces. Data providers, maybe researchers, companies, or individuals can securely monetize their datasets, while AI modelers or data scientists can purchase access to use that data for training their models. Their compute-to-data feature, which we discussed earlier, is really crucial for privacy. It allows AI algorithms to run directly on the data provider's infrastructure without the sensitive raw data ever having to leave its secure environment. This is huge for unlocking valuable data silos, especially in fields like healthcare or finance, where data privacy is paramount. Ocean provides the vital decentralized data sharing infrastructure for the ASI Alliance. Numeraire NMR is particularly fascinating because it's not just a plan, it's a real-world, proven application that's been running for years.
Oh, yeah. What do they do?
NMR is the token associated with Numeraire, which is essentially a hedge fund powered by crowdsourced AI predictions. Thousands of anonymous data scientists from all over the world build sophisticated AI models to predict financial markets.
Okay.
They stake NMR tokens on the confidence of their models' predictions. Numerai then takes the best performing, most confident models, combines their signals using its own meta model, and uses that collective intelligence to manage a real-world stock portfolio.
Wow, so they're actually trading based on this.
Yes, successfully since 2017. It's a brilliant showcase of blockchain enabling crowdsourced AI. It perfectly aligns incentives data scientists get paid in NMR if their models perform well, while using cryptographic techniques to obfuscate the underlying trading data, protecting Numerai's strategy. It demonstrates the viability of token-incentivized AI collaboration for tackling complex, real-world problems. Cortex, CTXC, takes a different approach. It's a blockchain network specifically focused on enabling on-chain AI model execution.
Like the internet computer example.
Similar goal, different technical approach.
Yeah.
Cortex has designed its own blockchain and virtual machines specifically to allow smart contracts to directly include AI inference instructions within their code.
Okay.
The idea is that the miners, or validators, on the Cortex network actually execute these AI models as part of the block validation process, doing it deterministically so they can reach consensus on the AI's output. This makes the AI's result an integral part of the immutable blockchain record. Developers could potentially build AI-powered apps on Cortex, maybe complex prediction markets, or games where the non-player character, NTC behavior, is driven by AI logic that lives and executes directly on-chain. It's a bold attempt to weave AI computation directly into the fabric of the blockchain itself. Singularity DAO, SDAO, is actually an interesting offshoot of SingularityNet, applying AI specifically to the world of decentralized finance, or DeFi.
So AI for managing crypto.
Exactly. It's a
Yeah.
decentralized asset management protocol. They use AI-driven algorithms to actively manage baskets of crypto assets, which they call Dynasets dynamic sets.
How does the AI manage them?
The AI constantly monitors a wide range of market signals, prices, volumes, sentiment, on-chain data, and automatically optimizes these portfolios. It might reallocate tokens between different assets, engage in hedging strategies, or participate in yield farming opportunities, all done algorithmically based on its analysis and risk parameters.
Okay.
What's particularly unique here is the decentralized governance over the AI strategies themselves. Holders of the SDAR token can vote on things like which assets should be included, what risk levels are acceptable, or even which AI strategies should be deployed. It's a fascinating blend of automated machine operation with human oversight and strategic direction via the DAO. VLS, the LS, is an example of AI being integrated at the most fundamental layer. It's a high-performance blockchain that claims to integrate AI directly into its core consensus mechanism. They call it AI-enhanced delegated proof of stake, or AIDPass.
How does AI help consensus?
According to Velas, the AI component continuously analyzes network conditions and optimizes the selection of block producers, validators, and adjusts the block generation process itself, aiming for optimal throughput and low latency. They claim this allows them to achieve very high transactions per second, TPS. Whether the AI component is truly central to this performance is debated, but Velas clearly exemplifies the concept of embedding AI right at the infrastructure layer to try and achieve significant scalability improvements. And do one last honorable mention. ChainGPT. CGPT. This is a newer project, but relevant. It focuses on combining AI, specifically using GPT-like large language models, with Web3 development and security.
So AI tools for crypto developers.
Essentially, yes. They offer things like an AI chatbot specialized in crypto knowledge. It can help generate or audit smart contract code, explain complex blockchain protocols, answer technical questions for developers. They're also working on developing something called an AI virtual machine, AIVM, intended to make it easier to run AI models within blockchain environments, acting as a kind of service layer to lower the barriers for building AI-powered dApps in Web3.
That's a great overview of the diverse approaches. What seems to tie all these pioneering projects together?
I think what they fundamentally share is this core belief that blockchain's unique properties, its decentralization, its openness, its ability to create aligned incentives through tokens can either dramatically improve how AI is developed and governed, or provide a way to deliver AI's benefits more democratically, more transparently, and more fairly to the world, breaking free from centralized control. They are truly pushing the boundaries of what both AI and blockchain technology can achieve when they work together.
Wow, okay. What an incredible deep dive into this really dynamic and evolving landscape. We've covered such vast territory today, from seeing AI acting almost like an autonomous member within DAOs to exploring intelligent adaptive smart contracts that can react to the real world.
Yeah, the smart contract.
Exactly. And even seeing how AI is shaping the very backbone, the infrastructure of blockchain technology itself. It's really clear that AI is stepping in to help solve some of the key pain points that Web3 has faced. Things like governance, scalability, participation, security vulnerabilities.
Definitely addressing real needs.
And in turn, Web3 seems to be opening up entirely new paradigms for how we think about AI. Things like community-owned AI models, truly transparent and tamper-proof execution environments. It feels like the journey is really just beginning, but the implications already feel enormous, promising smarter, more efficient decentralized systems and maybe a more open, more accountable approach to AI development and deployment overall.
Absolutely. And if we try to connect this to the bigger picture, looking ahead, it seems highly likely that we'll see DAOs routinely employing AI advisors or agents, making their governance much more data-driven, more efficient. Smart contracts will almost certainly evolve to include AI-powered clauses, especially for complex agreements in areas like finance or supply chain management, allowing them to handle contingencies intelligently and adapt dynamically.
Making contracts truly smart.
Exactly. And the blockchain protocols themselves might continue to evolve under AI's influence, perhaps leading to those self-optimizing networks we talked about, networks that can efficiently adapt to usage patterns, security threats, maybe even energy constraints without needing constant manual tuning by developers. Looking even further out, long term, this combination of AI and Web3 could potentially enable entirely new kinds of organizations. Ones that run largely autonomously, with minimal direct human oversight, coordinating maybe billions of IoT devices or autonomous software agents on a global scale.
That is staggering vision.
It is, but it also raises a really profound question, maybe a final thought for you, the listener, to mull over. As AI continues to grow more powerful and as it integrates ever more deeply with these decentralized autonomous systems, how do we as designers, as users, as a society, ensure that fundamental values like transparency, accountability, and fairness remain absolutely central?
Yeah, how do we keep it human-centric?
Exactly. How do we prevent this incredibly powerful combination from inadvertently creating new forms of opaque control, those AI kings or inscrutable algorithms we worried about? How do we instead proactively build a framework, maybe using Web3's own tools, that ensures this convergence is truly equitable, truly beneficial, and ultimately accountable to the collective good? This is so much more than just a tech buzzword. It's a deep, multidisciplinary evolution that could genuinely redefine how we coordinate, how we make decisions, how we create value together on a global scale. It could potentially position Web3 as the open, trusted operating system for a future increasingly filled with intelligent agents.
That's a powerful and really crucial thought to leave everyone with. It's not just about what's possible, but about building the future responsibly. Thank you so much for guiding us through that complex landscape. And thank you for joining us on this deep dive into the fascinating, challenging, and incredibly important intersection of AI and Web3. Keep exploring, keep questioning, and we'll catch you next time on The Deep Dive.